All right, this is the Python workshop brought to you by DubsTech. We're going to have some fun time with Python. So welcome to DubsTech. We are a UW RSO for diversified tech fields, and we aim to bring the coolest tech to everyone. Please like us, share us on facebook.com/DubsTech. And about this coding intro workshop, you are expected to learn how to code in Python and also explore your interest in coding. There will be new projects for every workshop, and all you need to do is to bring your laptop. And there will be no rushing, no homework, and no stress. So how this workshop works. At the beginning of every session, I'm going to show you how this finalized project works, and then I'm going to talk about the general aspects behind it, and then I'm going to walk you through the coding, and that's it. Everyone will get their projects completed, and we will appreciate enormously if you can show your projects to your friends and help us grow. So before we start, I want you to go to sunny.org and download the latest version of Sunny. And the download links can be found on the upper right corner. And for Macs, please refer to this link. And I want you to launch Sunny. It's a beginner-friendly IDE or code editor, to like a common name for it. And then I want you to create a dedicated workspace folder and please store all your codes in one place. And I'll show you the website right now. It is sunny.org, and the links can be found right here: Windows, Mac, Linux. And if you're a Mac user, you might be unfamiliar with installing a third-party application. So just refer to this website for the installation. And what I mean by a dedicated workspace is that this is my workshop workspace. You can see that I have all my codes in one place. It is very important for you as a programmer to store all your codes in one place. That helps you to organize and so on. So for today, we're gonna be doing a dice rolling simulator. I'm gonna show you how it looks right now. So this is the run button. Click it. It says the first dice roll a 3. Do you want a second roll? Type yes or no. I'll type yes. The second dice roll a 2. Let's launch the program again. The first dice roll a 5. Do you want a second roll? Type yes or no. I'll type no. And the end. All right. I hope you enjoyed that little game. So before we move on, how complex do you think the program is? Like, how many lines of code is there to complete this whole project, this simulator? And what aspects of coding do you think this simulator includes? How does the program accept and process our keyboard input? How does the program roll a fair dice? And how does the program tell you the number? I recommend you to pause the video right now and think about it before you move on. All right, here's a review. So let's count the lines right here. That's all there is. And there's only 15 lines of code. Just 15 lines of code, and that's including blanks. But then this project includes input output, so that's IO for short, and if else iteration, and also the helper methods. All right. So we're about to code, but then I want you to code step by step. What I mean by step by step is that everyone makes mistakes. And if you don't code step by step, if you just try to punch all the lines of code in like 5 minutes or so without checking all the individual parts, blocks of your code, you can mess up. All right. So bugs can build up and they can become harder to find. So I want you to think about the actions you make and the approaches or general functions that you make. So what I mean here is like methods are the codes that you wrote yourself. They are original. It's your own work. So methods help with factoring out codes and debugging. And approaches, I gave them a name, but they are actually generic functions. So these are built-in features or methods that you can use to save time. So let's roll one dice for now, because then in order for us to roll two dice, it's better for us to figure out rolling one dice, and then rolling the second dice will be relatively easier. What do we need? Well, we need the rolling action, and it's going to be original because Python won't be very nicely providing you with a method that calls roll and it does what we want, rolling the dice. We have to do that ourselves. But rolling, think of rolling. It's kind of like a generating random numbers that ranges from 1 to 6, and the part of generating random numbers will be generic. Python will provide you with the functionality to generate random numbers. If you're not sure about that, we will talk about how you can find out whether Python provides you with this functionality or not in a moment. So, and also we also need this output functionality that you output the number and the line saying what the number you actually wrote to the console, so the user can see. It's this part right here, this part. And that is also a generic functionality. So before we start, I want to go over some syntax basics. So I hope you can see the mouse right here. This define a method, def stands for define, and that is you write the def at the beginning to show to tell Python that you're writing a new method. And you can see all of the subcodes right here. They are indented by one tab. Or that is very important to Python, and I will explain that a little more later. So the parameters goes inside the parentheses. Right now we don't have any parameters, so we just leave it as blank, as what it is right now. So a text, so that's how you declare the name of a string, and the actual content of the string, the value of the string comes after. So this a text is hello world for now. And we also have integer 1, 2, 3, 4, 5, and that is attributed to a number. So variable names on the left, values on the right. And in Sunny, this is a part of the debugging part of the Sunny that helps you to figure out whether you have the right code or not with your intents and purposes. You can go to view and variables right here to check all the values and all the names of the variables that you've created for this project. And print a text that prints this string and only strings to the console, to the user shell. And there's also a return command that makes this method a returning method. And there are two types of methods. One of them I would call a returning method, and the others are the void methods. And I will explain this to you as well later. So in the main method, we have this print a method. So that prints 1, 2, 3, 4, 5 out because we are returning at the end of a method. And we also have at the very end of this Python file, we call the main itself. So that acts like a shortcut. So when you hit the run button, the main method will be executed directly. And so let's see that in action. It's the same code right here. When you click, let me clear the shell. When you click on run, it prints hello world. That is down through this line of code right here. And 1, 2, 3, 4, 5, that is being done by calling the main method as the shortcut. All right. So we've talked to you about some method basics. Now I want you to write your own method now. So go to Sunny, File, New, and call your new method hello world underline void. And what's important about the naming scheme right now is that you should use either camel case or underline to properly name your files and your variables. Because Python does not very like the spacing inside variables, it will just not compile. And we've talked about the strings and integers as data types, and we're going to introduce you to more of the data types in workshop 2. And we also talked about indentation is everything to Python, like the code I showed you right here, and with a method and all the subcodes behind it, and also the print command inside the main. And you see that the shortcut main is not indented; it's parallel to the two defining initiatives right here. So indentation really works like paragraphs in essay. A new paragraph is started with an indent, and so is the Python, but it's like backwards. All the codes, the subcodes inside a method is being indented. All right, that's code for now. I'm gonna show you how to do that right now. So I want you to, before doing anything, save this. Save this in a dedicated workspace, and I have the workspace right here. I don't need that. Let's call it hello world. Hello world underline void. And so to define a method, we need def. Let's call it the method name hello world underline void. And remember, it does not return anything, so we are just gonna print the hello world string right here. And to we also want to write a shortcut so that when we click on the run button, it automatically runs this void method. So we're gonna write hello world underline void right here. Click on run. Hello world is being indeed printed. All right. So now you've seen that some words in Python are colored and some are not. Well, what do they do? So color words, especially with these ones, not those ones that are string, but those ones right here, different IDEs, different code editors will have different colors of reserved words color scheme. You don't have to worry about that, but just know that when you cannot, I'm sorry, you cannot use those words as the names of your variables. They are reserved, and you just cannot use them. They have certain meanings, and they have their own functions. All right. So now we are going to talk about returning methods and to code one of your own. I want you to name this time hello world without the void. And before you write, I just want to briefly explain that void methods doesn't work on access, and returning methods return something upon accident. So if you refer to the syntax right here, it returns this number right here. And then to actually print it to the console, we need to write a main method and print what is being returned by this method right here. So I want you to pause for a moment, and I want you to write your own hello world file. All right, let's begin. So let's create something. And without further ado, let's save this and give it a proper name. Let's call it hello world.py. Let's write the codes out. Define hello world. with no parameters and with a single column right there to tell Python that we are starting to write a new method. And return the message, hello world. And we also want to write our main method. So that prints the hello world function method, and to call main as a shortcut. Oh, sorry, I messed up. So yeah. So you see that was a bad example. Sorry about that. But the naming of the methods is very important to Python. Anytime you mess up something, Python will complain about it. So it's really important to be consistent. All right. So now we know how to write methods, declare the methods, declare a string, and to actually print a string to the console. Right now we want to get random. We want to implement the generating random number functionality. So I want you to create a new file called randomdice.py without further ado. And I will explain how to write the random number generating functionality. All right, here we go. So create a new file called random dice. So save it right now, call it random dice. And so remember I talked about how Python provides you with the functionality of generating random numbers. You can do that by writing using the import command and import random. So Python has a random class by itself. We're just using the class, and we don't have to implement all the functionalities that random provides us. We just need to know how to use them. All right. So I want you to write to define a new method called row, and we're gonna call our very own variable num road is equal to random.rand int comp16. So what does this do? Random, that is referring to the random class that we imported from the Python library, and rand, that stands for random, and int stands for integer. 1,6 refers to the range of numbers that you want to generate. All right. And we want to return this number at the end of generating. Return num road. All right. And now I want you to write a tester to test this whether the routing functionality is working or not. And so let's also define a variable. I want to do this purposely. Num road. Oh, wow, they have the same name. Will it work? Will Python complain about this? We'll see about that very shortly. Row, and we want to print num road. And at the very end, we want to write a tester as our shortcut. So let's see. Seems to be working. Let's try again. It is definitely working. It's printing random numbers as we wanted the program to do. Cool, so far so good. So as you've seen what I mean by coding step by step, so that is before you get all the inputs, all the messages like this dice road is something. We don't want you to do that right now. I want you to test the row command, the row method before we do anything else further. So writing tester methods helps with locating bugs ASAP. And notice we have this num road and num road, both of them with the same name right here. They do not interfere. Python didn't complain about it. The reason being, methods only exist. Variables only exist in methods. So these are called local variables, and Python only knows about variables inside the tester. So you cannot create a second num_row in the tester method. But different methods, different variables can have the same name in different methods. But it's not a very good practice with that. I don't recommend you to do that. I'm just showing you the case that you can do this, but it is appropriate that you can just get rid of this and print the row right here. Because row is going to return this num row and it's going to be directly printed. So see, it does the same thing. So you can do that, but it's not recommended. All right. So you've seen that the methods, the variables inside methods don't have access to all the other information in other methods. But sometimes we want to share information. We want to share the contents of this one variable across our entire program. So how can we do that? We can use a global variable that is accessible to the entire program. And we're going to do that in workshop 2. All right, so now I want you to create a new file called simpleDice, and we are about to complete the project for rolling one dice. So we want a main method to print out a message, not only the number itself. That's what our tester did. So we want to improve upon that. So the reason with having a main method and instead of just call methods for direct execution at the very end is like other Python allows you to do that. It is okay, but there's a tradition from other languages like Java, like C++, so that you keep the rule of calling the methods, all the methods, like there will be 10, 20 as you move on and become a better programmer. But then at the very end, you just want to call the main method so that you want everything to be stored in one place. You want to be concise and consistent, just like with our workspace practice. All right. So let's create a new file and save it as simpleDice. And we are about to code. So let's borrow this code right here. And we want a main method. So let's get rid of the tester right here and also the shortcut. And define a main method. And row is equal to row. So that's how you declare a variable that copies on the contents of row, but we don't have to necessarily do that. You can just use the print command. All right, and you row a, and we want to also print the row, the number being returned by the row method, but then this is not okay. Python will not accept this. This will give you an error. So I want you to add a comma right here so that will be nicely separated. There will be a space between this you wrote a message and the row, the number that's generated by the row. And let's see that in action. You wrote a 3. You wrote a 2. Okay, seems to be working. All right. So now we know how to roll one dice, but in our original program that I showed you at the beginning, we want to roll 2 dice. So right now we're going to add functionalities to the main method so that we can roll the second dice. And it's not going to be that complicated because we already have our roll method. And so to roll the second dice, we only have to just call the roll method again because we assume all the functionality is being taken care of by the row method. So we don't have to worry about that. So that is the benefit of coding step by step. All right, I want you now pause the video and give it a try by yourself. And here we go. So create a new file and save it as random as simpleDice.py. All right, let's borrow the code from simpleDice. And we're just gonna print the second dice, road A, and to separate the command, we're gonna use a comma like this one right here. So let's run it. You wrote a 3, and then the second dice wrote a 4. All right, seems to be working. All right, so now what we want to do for now. You've seen from the original program that the Python actually asks you whether you want to roll the second dice or not. So to make the rolling the second dice optional, and because user may not want it the second dice to be rolled, the user might think, oh, I just need the first dice. I don't need the second dice. But then if you do it anyway, well, it's okay, but user may not like it. We're just exploring new possibilities. All right. So to make rolling the second dice optional, we would need to accept user input and to actually interpret the user input. And based on that, we want to make parallel actions. So if the user says yes, I want to roll it, and then we're going to actually do it. If the user says something else, well, we don't want to. So I want you to refer to if-else.py right now. All of the files will be shared somewhere, and it's going to be accessible to you. And so if you load it up, you can see that number is equal to input, and that is being casted to an integer. So integer int converts proper integer strings back to integers, because input is going to take whatever that comes from the shell, and if that's a truly stranger by itself with no letters whatsoever, then it's going to be successfully converted back to integers. And if this number is greater than or equal to 0, it's going to print that number is not negative. Else, well, what would happen if the else statement is considered right here? You see, this if and else, they are being indented on the same level, but what the codes inside are being indented again twice. So one indent here, and that's 2 indents here. You can see the level right here quite neatly. All right. So when the program reaches here, you know that this is not going to be true. So the number has to be less than 0. And so it will print the number is negative. So let's see that in action. Give me a number. 3. The number is not negative. Let's do that again. Give me a number. I will get a bit 0. Number is not negative as expected. And let's give it a -1. And the number is negative. You see that? So we want to use double equals to convert to compare if things are equal, because we have already used a single equals to declare the names for variables. And unlike other programming languages, the Python compiler will complain that if you use a single equal instead of a double equal in the if statement, and to use exclamation mark equals to compare if things are not equal. And for those 4 symbols right here, you know the drill from math already. So, and we're about to complete the simpleDice 3. So if we ignore bad user input for now, what are the only two scenarios of input? If the user says yes, then we roll the second dice. All right. If the user says no, then we do nothing. We literally do nothing. So there's no need to write the else case here. We just need to check if the user input is yes, and then we roll the second dice. That's it. It's that simple. And we're gonna actually do more if-else logic in workshop 2. So I want to pause the video right now and give it a try using what you've already learned if-else from that if-else.py file. That should help you with completing this project. All right, here we go. So let's create a new file and save it without further ado. Workspace, let's name it simpleDice3. And let's borrow the code from simpleDice2. All right, here we go. So we're creating a new user input called, just thinking of a good name. Well, not really. Let's just call it row again is equal to input. Do you want a second row? Type yes or no. All right, so far so good. So if row again is equal to yes, then we want to run this piece of code. And if you get really fancy that the user, you might think that the user input yes, and we want that to work, well, you can use if row again dot lower, so that converts everything to the lowercase. So it will, even if you have something like this, it will convert to this. So no worries about that. All right, let's run it. You wrote a 5. Do you want a second row? Type yes or no. Let's type yes. The second dice wrote a 1. All right. So we're done for the project. And now let's think about it before we end this workshop. So in real world scenarios, we could never ignore bad inputs. So instead of yes or no, what happens when the user wants to type in LOL and just to mess up our program? Well, we have to prevent that. And what if the user wants to roll dice, but for like 100 times? Do they need to launch the program over and over? That would be really troublesome. And is there a way to loop the coding? Yes, it is. I'm gonna show you how to do it right now. So this is like a fixed, this is a program that fixes everything. Ready to roll, enter to roll. Enter, the first dice roll the file. Do you want a second row? Type yes or no. No. Ready to roll, I'll type LOL. Oh, you see the program did not crash. Because in our code, we said if roll again is not equal to Q, then we would do everything. And let's say no, LOL, bad input. All right, that is the error checking in action. And we want to quit. Thanks for playing. So there's 2 ways you can deal with this. You can just either choose to continue the game, like right here, or you can just give it like a bad input. It's up to you. So that's it for now. I will see you in workshop 2, where we'll fix all these problems and write our own Magic 8. This project is inspired from a project by a Webicator. So shout out to great folks there, and goodbye.